Hello and welcome to an introduction to quantum physics. This first chapter is called A Step into a New World. If you are interested in physics, quantum physics, how the universe was created, or just want to learn something new, you are in the right place. Quantum physics, by dictionary, is the branch of physics concerned with quantum theory. But it is so much more than just a science. Quantum physics rewrites classical physics as we know it today. It teaches us something that goes beyond this world. This new science, discovered in the year 1900, has revolutionized the way scientists think. Since then, theories like Schrödinger's cat, Planck's constant, Einstein's theory of general relativity, M-theory, string theory have been made plausible due to quantum physics. Hello and welcome to the basics of quantum physics. Before I really get into the depth upon the subject, I just wanted to make sure that people understand what quantum physics overall means. Quantum physics is the study or branch of science that deals with how different subatomic particles react with each other. Particles in an atom are protons, electrons, and neutrons. Outside the nucleus of an atom is electron shells. The particles between the electron shells are believed to be quantum particles. Between the electron shells of an atom is equivalent to almost a new world, called the quantum physical world, where the laws of classical physics are completely discarded. Follow along to learn more. Quantum entanglement is when two or more particles become connected at a subatomic level. An example of this is if you roll two dice and they both come up with the number 6. These two particles, represented by the dice, are telepathically communicating to each other faster than the speed of light, and telling each other what they're going to do before someone can observe them. So these two particles are communicating with each other, telling them what they're going to do, what the outcome is going to be, how they're going to act. And due to the observer effect, a scientist cannot observe that this is happening, and that's why the two particles are acting the same. I will discuss in my following video about the observer effect, so follow my page to view more videos. Today I'm going to discuss the observer effect. So this is simply when observing a situation can alter it. If you haven't already seen my video on quantum entanglement, I strongly suggest you watch that video before this one. A common example of this is the double slit experiment. When observing electrons being fired at two slits, they behave like waves and create an interference pattern, suggesting that they pass through both slits simultaneously. Whereas when the electrons are not being observed, the interference patterns disappear and the electrons behave like particles, going through only one of the slits, which is recorded through a detector. In this experiment, the scientist observing the electron altered the outcome of the study. This is the observer effect. Hello and welcome to a new episode of A Beginner's Guide to Quantum Physics. Today I will be talking about quantum tunneling. To have a greater understanding of this concept, I strongly suggest that you watch my other videos. Quantum tunneling is when a particle can penetrate an energy barrier that's higher than its own kinetic energy. In simpler terms, this means that a particle can move through an object that contains more kinetic energy than itself. Kinetic energy is the energy an object has when it is in motion. An example of quantum tunneling is a particle traveling through a door. Theoretically, in the quantum physical realm, which is the space between the electron shells of an atom, particles are capable of quantum tunneling.